Hi friends, in this session we'll discuss reading number 4 of CFA Level Quants, probability trees and conditional expectation. Now the chapter name is probability trees and conditional expectation, but we also have the Bayes theorem in this chapter. So we have three discussions in this chapter. So first is the probability trees, then you have the conditional expectation and then the Bayes theorem. So now here this is the note for students who are taking classes from the Falcon edifice. Now here, the preparation methodology, simply the method. So here we have, or you have two options. First is if you are very new to this particular area, that is like the probability area. So say, for example, you don't understand what is the concept of conditional, unconditional probability, joint probability, mutually exclusive probability, and so on. So if you are not aware of all these concepts, then my recommendation is to watch level 0 video of the probability, which is available in your app. And this video is from FRM's course, not separately recorded for you, because in FRM's course the probabilities coverage is complete. So it starts with the basic, and we also have all the discussions which are required for this chapter's understanding. Now here what happens, CFA Institute assume that the students who are coming for CFA level 1 already know all these concepts, and that's why all the concepts which I told you about, so all these concepts are deleted or removed from the curriculum starting 2024 session. So here my recommendation is, if you are not aware of all these concepts, then start with level 0 of FRM, which is, as I said, available in your app with this chapter itself. And make sure you don't need to solve any questions. Okay, so no question solving is required for level 0. And then you have to watch this video. If you know all these concepts, then you can directly start with this video. Fine. So these are the two things. Now, one more thing. If you are not aware of the fundamental concepts, then it will be very difficult for you to understand the discussion in this chapter, because all the basic which is required to understand this chapter is removed and covered in the level 0 video. So please make sure that you watch this video. This video is long, so I guess it is like 2 hour long. Level 0 is 2 hour long, and it is still worth watching that video, right? So let's start with the first discussion of this chapter, which is on the expected value and standard deviation. Now here, this particular concept is related to the previous chapter. In previous chapter, we discussed the mean, right? So mean and standard deviation. Now, the mean and standard deviation, which we learned in the previous chapter, is related to the historical data or the empirical data. Now here we will calculate the mean and standard deviation only, but we won't call the mean as mean, we will call mean as expected value, because here we will see how to calculate the mean, which I'm using term mean for your understanding. The actual term is expected value. So how to calculate expected value for the data which we are forecasting. So for the forecasted values, how to calculate the expected value and the standard deviation. Now here in the learning objective as well as in the curriculum, we have formula for the expected value and standard deviation, but please note, you don't need to worry about the using formula in the exam, because if you use formula, it will take a lot of time. One. Second, we have calculator, financial calculator, and in financial calculator, we have the function which gives direct result for the expected value in the standard deviation. If you know how to use the calculator, we will see how to use the calculator in this video, so don't bother about it, right? So let's start with the first part of this section. We'll directly start with the illustration, and then I will explain you what is the actual meaning of the expected value. What is the specific meaning of the expected value? Now here, we'll take the example of stocks EPS. We will call this as X, variable X, and the EPS forecast at the year end is, say, 10, 12, 15 and 18. These are the 4 possibilities for EPS of this stock X. Now here, because it's the forecast, we will need probabilities. Now here we have the probability of X, and probability of X simply tells you like what is the probability of getting this EPS for this stock. Okay, so it is 20%, 30%, 25% and 25%. This will always total to 1 as it, like the 100% probability should be captured here. And this gives us the collectively exhaustive event. So here we have all the possible situations, that is the EPS of stock and all the 4 possible scenarios, right? So for this reason, we have specific probability. So what is the probability of the EPS of this stock will be 10. So probability is 20%. What is the probability that stock's EPS will be 18 at the year end? It's 25%. And this is how it works. Now the simple question is, what is the expected EPS? Expected EPS. Now for the formula is very simple. Summation of xi multiplied by p, probability. Simple. Okay. So this simply means you have to multiply the probability with the individual values and then take the summation. Again, this formula is similar to the mean calculation, which is like simply for the mean we use formula xi, summation of xi and divided by n. So here, if you use the n as the proportion, so if you use the weight of the n, then you can again use the formula like this, even in the means case. But here we don't need to bother about it. We will simply focus on this particular discussion, the expected value of x, or simply the EPS in our case. Now here, the first step here is simply you have to multiply EPS by probability and simply do the calculation here. So it's 0.2 multiplied by 10, it's 2, then 0.3 multiplied by 12, is 3.6, then 0.25 multiplied by 15 is 3.75, and 18 multiplied by 0.25 is equal to 4.5. Now I have to simply take the total of this. So 4.5 plus 3.75 plus 3.6 plus 2. And the answer is 13.85. Summation. This means the expected value of the EPS is 13.85. Now understand the meaning of this expected value. So this expected value is 13.85. This does not mean that at the end of the year you will see the EPS of 13.85. The probability is very low that you will get exactly 13.85, or I can say it is almost zero to get the value exactly equal to 13.85. This particular expected value of 13.85 simply means that there is high probability that your EPS will be around this value, near to this value, and low probability that the EPS will be away from this value. So if we plot the distribution, the probability distribution, it will look like this. Again, if you don't know how the probability distribution works, don't bother about it. We will see the probability distribution part later. So now here, this is the value 13.85, expected value of the EPS. And here we have EPS. So this zone is the indicative of probability. This indicates the probability. So higher the area, like more area is near the 13.85. That's why the probability is really high that your EPS will be around 13.85. Definitely, we are not saying that it will be exactly 13.85, but it will be around 13.85. There is one more interpretation of EPS. If you get the chance of seeing this EPS again and again, if this particular situation, exactly this situation happens, say thousands of times, multiple times, that you are forecasting for the stock and you are getting exactly same values, the 10, 12, 15 and 18 EPS with these specific probabilities. So every time you will get different EPS. But if you take the average of those values, you will get 13.85. And this is what is this discussion? So understand this. We are talking about this particular setup. You are able to observe this particular setup for thousands of times, in thousands of situations, thousands of different situations. You can say, like, you are going back in time and again you are coming to that specific EPS and you are calculating, counting that EPS. And if this is happening again and again and again and again, then your average value of all the EPS will be 13.85. This is again one more interpretation of EPS. But here, just simply understand, for your understanding and for our industry, So this meaning of expected value of the EPS simply means that there are higher chances that the actual EPS of this particular stock will be near to 13.85 than the probability is higher than the values which are far from 13.85, right? So this is about the expected value. Now we will see the calculation of standard deviation of this EPS. Now, formula for the standard deviation of the EPS is, again, the formula is very simple. This is under root. Again, this is related to the previous discussion. Here we have x minus x bar. I'm writing it as x bar, but the actual term I should be using is expected value of x. I should write it, this x bar should be written as ex. But just to make sure here it is easy to remember, I'm writing it as x bar. Okay, and then square multiplied by probability, like this. Okay, this is the formula for expected value of EPS, sorry, standard deviation of EPS. Now to do the calculation, what we have to do, we have to simply start with the calculation. First, we will calculate the distance from mean, which is x minus x bar. As I said, I'm writing x bar for the understanding and memorization purpose, but the actual term in the x bar should be expected value of x, E of x. So first we have to calculate the difference here. So the difference is x minus x bar. So 10 minus 13.85, and this is minus 3.85. Then 12 minus 13.85, it's minus 1.85, and I have all the values noted here. So I'll simply write down values from my already done work, and this is 4.15. Okay, so these are the values, and next step is we have to square it. X minus x bar square. So you have to square 3.85, then 1.85, 1.15, and 4.15. I will simply note down the values which are available with me. So 14.82, then we have 3.42, then 1.3, 1.32. Let me just do the calculation. 1.15 square. Just a second. 1.15 square. Yeah, so it is 1.32. Then 4.15 square, 17.22. Now you have to take the total, and total of, that is summation of x minus x bar square. Sorry, you don't need to take total. You have to again follow one more step, which is probability multiplied by x minus x bar square. Here we have to multiply it by probability, and then we will take the summation. Okay, now what is the probability? So probability is this. So here 14.85 multiplied by 0.20, answer is 2.964. Then 3.42 multiplied by 0.3, answer is 1. Just a second. So 0.3 multiplied by 3.42, answer is 1.0026. Then 1.32 multiplied by 0.25 is equal to 0.33. And then 0.25 multiplied by 17.22, answer is 4.306. Okay, now you have to simply take the total of these values, and the total is 4.305. 305. Just a second. 305. So 4.305 plus 0.33 plus 1.026 plus 2.964, and the answer is 8.625. So here we have our answer, which is 8.625. Then you have to take the under root of this, and the answer is 2.936, which is 2.94. So the standard deviation of this EPS is 2.94, and the expected value of the EPS is 13.85. So here we use the full method, and as you can see, this is not practical to do it in the examination. If you get questions, say there are 4 values, and say institute asks you to calculate the EPS, expected value of the EPS or standard deviation of the EPS, then it is very difficult to do the calculation this using this particular method. So what we will do, we will use calculator. Okay, so here in calculator, just see how to use the calculator for this purpose. Now first we have to feed the values. So for this you have to simply click on second data, and here you will have x01, and if you press down you will have y01. So in x01 you have to feed the x values, and in y01 you have to feed the probability values. But remember, the probability should be filled as in total percentage, not in decimal format. So for 20% you will use 20, simple. So now see, so I'll start with the feeding values. Make sure you clear all the previous values. Here we'll start with the 10, enter, down. 20 is the probability, enter, down. 12x, 30 probability, enter, down. Then 15, enter, down. 25, enter, down. Then 18, enter, down. And then 25, enter. Okay, now we'll just verify our values. So it is 10 probability 20, 12 probability 30, 15 probability 25, 18 probability 25. Correct. Now here you have to press second stat. Right now I have this, like, you will be able to see your calculator in this particular mode, which is lean. Okay, so LIN stands for linear regression. So this is the linear regression mode where x and y values are treated as two variables, and this calculator will give you all the values for the regression analysis. You will get the alpha and beta also, right? So but we need the probability calculations, right? So for probability calculation we have to enter this calculator into 1V mode, and to enter it into 1V mode you have to press second set, second set, second set, second set, and this is 1V function. Now if you press down, you will see n is equal to 100. What is the meaning of this? 100% probability is captured. If you fail to feed 100% probability in y, if your total is not 100, you will get error. So now n is equal to 100. If you press down, you will see x bar, which is expected value of this EPS, is equal to 13.85. Just verify this. So this is the value, 13.85, right? Our value is correct. Then you have to press down and again press down, and you will see standard deviation of x. Please remember, here don't look for Sx, always look for sigma x, and this is the value. Okay, so there is an approximation error. We approximated a lot of values, so that's why in calculator the value is 2.937, which is again approximated as 2.94, and our standard deviation is 2.94. Rest of the values are not important for you, so just make sure. So to make sure that your values are correct, simply look for n is equal to 100, and then these values are there. So in exam, if you get this question, use calculator. It is not practical or possible to use the whole table method. And this also means that you don't need to bother as such about these formulas. Just remember these formulas. It is good to remember the formula because it will develop habit of, you will have the good habit of remembering formulas. But other than this, you don't need to remember the formula because you can always use calculator in the examination, right? So this is the first discussion, first learning objective on the EPS calculation. Now we have next learning objective, which tells us about to do the calculation on the probability tree. So for this, I will simply show you the example, and the example goes like, again, institute asked provided learning objective specifically tells that use the example which is investment related. Okay, so we will use the general investment related example where we have the economic condition, which is like economic expansion, economy is expanding, and we will say this is as P of E, probability of expansion in the economy, and not expansion is P E naught. Okay, so this is how it works. Then assuming this happens, for example, the probability of expansion, so expansion happens, there is a probability that we will see company giving us good results in the form of EPS. Okay, so good EPS. And the second is not good result, we will write it as or not. Okay, so these are the probabilities, and now we will first feed this particular probability tree. At the same time, I'll also explain you what this probability tree means, what is the meaning of the probability tree. So let's start with the first First is probability of expansion in the economy, and let's assume this probability is 0.25, and probability of not expansion in the economy is obviously it will be 0.75. Again, this particular domain, this to understand this example, you must know all the basics, and please, if you don't know the basics, watch level 0. If economy expands, then the company will give us good results. Is the probability of good results is denoted as probability of good results. Remember, probability of R is good results, right? So probability of good results given expansion. This is how it is written. Okay, so probability of good results given expansion, and let's say it is 0.40, and probability of not good result, it is highly, like, it is possible, right? So even though the economy is expanding, company won't be able to give us a good results, and company won't be able to give us good results given expansion. This vertical line is for, like, the, we read it as given expansion. This means expansion happens first and then company gives us a good results. So here obviously the probability is 0.60, 0.60. So simple, remember, these two events, either economic will expand or it won't expand. So the total of these two, like the probabilities total of these two events, should be 100%. So probability of expansion is 0.25, probability of not expansion is 0.75, total is 100%. Here the probability of good results is 40%, not good results is 60%. But remember, it is given probability of expansion or economy expands. So this means 40% and 60% is 100% again. Now, here, if there is no expansion, still there is a possibility that company will give us good results. And here it will be noted as like this: probability of good results but not expansion, E naught. Let's say this is 30%. Okay, I'm reducing the probability, and then probability of not good results and no expansion is obviously 0.75%, 0.70%. Now always remember, these two should total to 100%, these two total to 100%, these two total to 100%. You can't simply take the total of all. You have to remember this, right? Now see this. Let's put the value of EPS in each situation. So results are good. Let's say EPS is 15. Results are not good. Let's say EPS is 7. Here again, results are good. Let's say EPS is 12. And results are not good. Let's say EPS is 5. Now here we have to answer single question, simple question. Now the question is, what is expected value of EPS, or simply what is the expected EPS? Now to do this calculation, expected value of EPS, that is simply to calculate the expected EPS, you have to simply first calculate the joint probability, and then multiply it with the EPS value and then take the total. So EPS multiplied by joint probability, EPS multiplied by joint probability, again second case, third case, again EPS multiplied by joint probability, again you will do the same thing here, and then you have to take the total of these multiplications. So first here we will need joint probability, and joint probability is calculated as 0.25. In the first case 0.25, remember this probability multiplied by this probability. So 0.25 multiplied by 0.40, you have to simply do this calculation. Then again 0.25 multiplied by 0.60. Here 0.75 multiplied by 0.30. Here we are multiplying like this and this. And 0.75 multiplied by 0.70. Okay, so now let's note down the values. 0.25 multiplied by 0.40 is 0.1. I'll just do the calculation for confirmation. Is 0.1. Then 0.25 multiplied by 0.6 is 0.15. Then we have 0.75 multiplied by 0.3. This is 0.225, and 0.75 multiplied by 0.70 is equal to 0.525. Now, 5 to 5. Now, see this. Assuming we did correct calculations, the total of these probabilities should be 1. Okay, that is 100%. So let's see the calculations first. Zero point 0.1 plus 0.15 plus 0.225 plus 0.525, and answer is 1. Perfect. So our calculations are correct. Now here, once you have the joint probability, we have to simply do this calculation. See this here, 15 is the EPS multiplied by its joint probability plus 7 multiplied by 0.15, again joint probability, plus 12 multiplied by its joint probability plus 5 multiplied by its joint probability, 525. And simply solve this and you will get the answer. So this will be our expected value of the probability. So 15 multiplied by 0.1, store it in 1, then 7 multiplied by 0.15, store it in 2. And one more thing, in case I make any mistake, please make sure you are doing it correctly, because I am using software version of this calculator. So sometimes it is difficult to use this calculator. Okay, sometimes there's possibility that I will end up pressing some wrong button. Okay, so make sure you do the correct calculation. 5 multiplied by 0.525. The answer is this. Now simply recall 1 plus recall 2 plus recall 3 plus recall 4, and the answer is 7.875, and this is expected EPS of the company. Expected EPS. Okay. So this is the second learning objective, where you have to do the calculation of expected value using the probability tree. So you should be able to understand how this probability tree works, be ready to prepare or be ready to do the reverse calculation also. In case you are provided with the say EPS value, then you should be able to do the calculation of say EPS at this particular point. So assuming like you are provided with the expected EPS and all the other values are provided, then, and let's say you are asked to calculate this EPS, this specific EPS, then you have to simply rework this calculation. This particular value will be considered as X. You will have EPS here and then simply equate it and you will get the answer. Again, the very 10 standard stuff, right? Now here we have the last discussion, and which is Bayes theorem. Now, in this Bayes theorem, we will take the support of this tree only. Okay, we will work on this tree instead of doing fresh calculations. I hope this is visible for you. Okay. Now let's see. Bayes theorem. Now here, the Bayes theorem is the separate domain of probability. In probability, we have the general discussion of probability, and then we have the spatial area of the probability, which is the Bayes probability. Now, Bayes probability is very big chunk, very big area. But here in FRM as well as in the CFA curriculum, we have very limited discussion related to the Bayes theorem. Now in Bayes theorem, we have to just understand how to update the probability given the specific event happened. Now understand how this works. Now Bayes theorem is applied in a special, is in this particular context. The Bayes theorem is applied in a special context or in very special scenario. Now here, assume that this particular company for which you are calculating all the EPSs, this is very new. So we don't have any historic data or we don't have any relational data of the EPS and the economic expansion. So we don't know, actually, we don't actually understand like how the expansion and the EPS of this company are related. But we have some basic calculation like this EPS of 15, 7, 12 and 5. Here we are missing on probabilities. So we don't have the exact probability values here. Okay, remember you won't have the results, because if this company, assuming this company is new, then you will miss on the values which are related to the good results and not good results. But you will know these values, right? So the expansion, but still assume like these are also the assumed values. We are assuming like there is a possibility of expansion, and the possibility is a probability is 25% and not expansion is 75% and so on. Now here, in this previous case, we assumed these probability values based on the historical data. Maybe we have some historical data, and based on this, we did this calculation. But if you don't have historical data, as I said, like assuming this company is very new, then in this case, what we are assuming here, we are assuming that based on the common sense, based on our logical understanding and some indirect data, we will first feed some basic values in this probability tree. These are basic values, these are assumed values. Now when you are entering into the Bayes theorem or Bayes domain, this is how it works. So these values are assumed and based on some indirect information or logic. So we are assuming the probability is 25%, probability is 75%. Here the result good is 40%, result bad is 60%, result good 30%, result bad 70%, like this. So these are assumed values. Now, when you have these assumed values, what we do here, we do the calculation of updated probability. Updated probability based on or assuming that the result happened or the specific event happened. And what is this event? The good result or the bad result. Now here we can update the probability assuming, I'm writing this as assuming the company gave good results. Okay, so company gave us good results. So this is how we are doing this calculation. So here we are updating probability of what? Economic expansion. Expansion or not expansion. You can take anything. You can do calculation for anything. But here we will assume the probability of expansion, economic expansion, and I'm writing it as E. Sorry, it should be like probability of expansion. Now, updated probability of expansion or not expansion, we will do this calculation and assuming you must have some additional information, and this additional information must be related to this. Remember, the good results or not good results, and then we will update the probability. So here I'll write down this statement. This is how the statement works, and you are likely to see similar type of statement in illustrations and questions. Given the company gave good results, what is the probability of economic expansion? Economic expansion. Now see this. Company gave good results is the first new information. This is the new information. This is the new information. And this is what we have to find. So probability of economic expansion. Now when we write this in the formula, we have to write it like this. So probability of economic expansion given the good results. Given the good results. Now note this particular point. This, like the given good results, is the indicative of new information. And here we are not indicating that this is given, like this is not the conditional probability. This is just the new information. That's it. Now to solve this, the formula is very, very simple. First of all, joint probability of expansion and good results. Here we will need the joint probability of expansion and good results. Why? Because we are doing this calculation for good results and expansion. So expansion, good results. Okay, so we'll use the joint probability of expansion and good results. And in denominator, we will take the total probability, also known as the unconditional probability of good results. Simple, very simple. So the calculation is straightforward. Joint probability of expansion and good results divided by total probability of good results. I will also show you second situation so that you are able to understand it in a better manner. So here, first of all, we'll need the joint probability of expansion and good result. We already have these values, that is multiplying by expansion's probability and conditional probability of good results given the expansion. So 0.40 multiplied by 0.25, and the answer is 0.10 in the numerator. Now you need the total probability of good results. Remember, this is the total probability of good results. So joint probability for this and this. So we have two good result situation. First good result is from here and second is from here. So this plus this, okay, two good results. That is good result given expansion and good result given no expansion in the economy. So first value is 0.10, second value is 0.225. 0.10 plus 0.225. And you have to simply solve this and you will get your answer. So the answer is like 0.10 divided by 0.10 plus, just second, 0.10 plus 0.5. Store it in 1.10 divided by, recall 1, answer is 0.2857, which is equal to 28.57%. Okay, so this is the first situation. Now we will do the calculation of probability of no expansion given no good results. So company failed to give us good results in the EPS form, and we have to do the calculation of what is the probability that these poor results are based on or are conditional upon the no expansion in the economy. You can also do the calculation for the expansion in the economy. It doesn't matter. So here we are calculating it for no expansion in the economy. I'm just giving you the second scenario to give you the better understanding. That's it, right? So here, as I said, first in the numerator, you will need the joint probability of these two situations. Joint probability of these two situations. And where is the joint probability of these two situations? So first is no expansion, no good results. Joint probability is this. No expansion, no good results. Joint probability is this. I have to simply multiply these two. So here in the numerator we have 0.525, and in the denominator we will need the total probability of poor results or simply the no good results. Here for no good results we have first situation and second situation. Remember, the total probability, unconditional probability, marginal probability, all are the same thing, and to do this calculation you have to simply take the total of all possible situations for the specific event. So poor results, that is no good results, can come from poor economic conditions, that is no expansion in the economy, or good economic conditions, that is expansion in the economy. So poor result, expansion in the economy, poor results, no expansion in the economy. So 0.15 plus 0.252. This is 0.15 plus 0.525. So 0.15 plus 0.525, store it in 1, 0.525 divided by, recall 1. And the answer is 77.78%. And this is your probability. So this is how it works. So for homework, do these calculations. So probability of no economic expansion given company gave good results. And again, as I said, this is your new information. And the probability of expansion given the results are poor. So you have to do the calculation for these two. Okay, so if you have any doubts, you can ask me related to this. Right, so mainly like this is the area where you may find some difficulty. If you solve few questions, you'll be able to handle this area. Okay, not very difficult area. Right, so that's all for this video. Thank you and thank you for watching this video. See you in the next video. Bye bye. Take care.